134. All righty. So we are going to talk about some vector operations. We looked at vectors yesterday, talked about some different forms, and so we can multiply, and we can add, and we can subtract. So let's just talk about these, and then we'll look at what it looks like. So a vector can be multiplied by a real number, k, called a scalar. So when you talk about scalar multiplication, y'all did matrices in Algebra 2? Yes? Okay, so there was something called scalar multiplication that you did with matrices. It's the same type of thing. It's very simple. So this will change the magnitude of the vector, because remember the magnitude, it has to do with the length. If the k is negative, the vector will reverse to the opposite direction. The figure at the right shows that. So if this is v, then this is 2 times v, so it'll be twice as long. But it'll go in the same direction, same everything else. 1/2 will be half as long, and then the negative just makes it go in the opposite direction. Okay. So when we add vectors, a geometric representation of the addition of 2 vectors, v and w, is shown to the right. So because you can move, you can like pick up the vectors and move them around as long as you don't change the angle or the length. Yeah.
So w equals negative w because of the same size.
Right. Yeah. Yes. The absolute value of them equals that. Yes. Yeah. So I can move them. Like even if I took these 2 and I wanted to add them together, or take like, isn't 2v v plus v? It's the same thing, right? So I could take one of these and I could just duplicate it, and then I could put it on the end, and then I would be adding the 2 together. So when you have v plus w, you have v here, okay, the tail and the tip here, and then you just start the other one where the other one ended. And you've got those 2 together. There's v plus w, okay? Shortest distance between 2 points is a straight line. The vectors are positioned so that the tip of v coincides with the tail of w. The sum of the vectors v plus w, called the resultant vector, so that's a word that'll come up again, extends from the tail of v to the tip of w. So you just kind of think about how you can snap them together and then you connect them to make a triangle. To subtract them, so if I want the difference of 2 vectors, v and w, it's defined as v minus w, but you can always change subtraction to addition. That's actually how it's defined. It may be how you were originally taught subtraction, I don't even know, but you change this to plus a minus, right? So v minus w is the same as v plus negative w, which is going to reverse the direction. So a geometric representation of the difference is over here. So here's v. And then since we took w and we had to reverse the direction, it's now coming this way. So this is actually what v minus w is, okay? And the whole tip to tail, I don't know if you've heard that phrase, but it talks about, you know, blah, blah, blah from tip to tail. And it has nothing to, usually when people say it, it has nothing to do with vectors. It just means like the whole thing or whatever. But it's kind of one of those old-timey phrases. That's where it comes from. All right, so let's look at what we have. We have vectors v and w. Now remember, these are bolded, okay? When we write them, we can't really write bold. I mean, we kind of can, but it's still kind of weird. So we'll use the little symbols, but it's not that the symbols are missing on here. It's just that they're using the form of the bold. Does that make sense? All right, so if this is my vector, remember, you have to have these pointy brackets, right? It's a1, b1, and w is a2, b2. So it says these are vectors, and k is a real number. That's going to be our scalar. So scalar multiplication looks like this. This is v, which is a1, b1, right? So that means that k times v is just going to be k times a1, comma, k times a2. I'm sorry, b1. Dang it. Good Lord. I'm using this right here, and I just didn't write down right. b1. a1, b1. You literally just take k and you multiply it by both numbers in your vector. That's it. Addition is super simple also. And remember, we are using these 2 up here. If I'm going to add these 2 vectors, it looks like this. a1 plus a2, comma, b1 plus b2. It's just like if you were to add ordered pairs. Same thing. You just literally add the x's, add the y's. We don't mix x and y. So to subtract them, same thing. a1 minus a2, comma, b1 minus b2. So the biggest hang up on this, or the thing that's going to get you in trouble, is the signs more than anything. Honestly, it's just going to be, if you're going to mess up on anything, which you very well may not. So you do have to show a tiny bit of work the beginning of this stuff. I want 2 times c. So that means that that's going to be 2 times a negative 4, comma, 2 times 5. Like you have to write that part down. And then you can say 2 times c is equal to negative 8, 10. And you're done. That's it. Easy enough. All right, so then we have a plus b. So I'm going to do negative 6 plus 1, comma, 2 plus 7. So that means that vector a plus vector b is equal to negative 5, 9. Everybody okay with that? It is simple. Now you do number 3. Oh, let's see. Oh, let's see if we can do number 3. Yeah. It's really not any harder. Y'all agree with that? All right, so number 4 isn't necessarily any more difficult. I'm just going to show you how to make sure that we know how to write things in there. It's a minus 3c. So a is negative 6 minus 3 times the first one, and c is negative 4. Then you have to have that comma. Then it's going to be 2 minus 3 times 5. And then you don't have to write any, there doesn't have to be any extra steps, but if you feel like there needs to be so that you don't mess anything up, that's up to you. But probably don't need to. So I've got to multiply. Can I do negative 6 minus 3 first? No. So I do negative 3 times negative 4, which is a positive 12, and then a negative 6 gives me a positive 6. Negative 3 times 5 is a negative 15, and a positive 2 is going to be a negative 13. Any questions at all? Alrighty. So then you do 5 and 6. Not okay anymore? Oh, yeah, sorry, it's on the other side, so you got it. You can rewrite them on the top if you want. Here, I'll leave them where you can see them, and if you want to write A, B, and C up there, you can look up here. You can see mine. Okay, yeah, you can just look up here. No, there should be no decimals. No decimals. What questions do you have? All of the questions. All right, let me work. Are we stuck on, is 5 the one that's causing issues? All right, let's do 5. Okay, I'll work through both of them. All right, but I got to see my A and my B here. So here, on this one, I'm going to get 1/2 times negative 6, thank you, minus 1, thank you, and then 1/2 times 2 minus 7, thank you. All right, so 1/2 times a negative 6, negative 3, minus 1 is negative 4. So this 1/2 A minus B equals, I got negative 4, and then 1/2 of 2 is 1, minus 7 is negative 6. Okay? So I need to do number 6 also? Do it. Yeah, I'm going to give you some time. That's what I was trying to do. But then everybody was getting stuck, so I wanted to make sure we knew what we were doing. Oops, I went the wrong way. There you go. Do you all have it substituted in already so I can turn the page? And then I'll start writing it down. Okay. All right, so I got 4 times. So 4. So, I mean, if you need to jot something down when you're multiplying multiple things, that's fine, but you don't even have to go in order here. I would look at this as negative 30, and then I have a positive 4, so that's going to give me a negative 26. And then I have 28 and 10, it's going to be 38. Yay! You got it? We good? No, that's not what you got? Did you set it up correctly, or did you just like we multiply wrong? Okay, if you did not get that, do you understand what you did? Yeah, so B is, what was it? 1,7, and A is negative 6,2. So I'm going to do 4 times 1 plus 5 times a negative 6. And then I'm going to do 4 times 7 plus 5 times 2. Yeah? Does that help? Okay. All right. What questions do you have? Nothing? We're good? All right. So let's look at unit vectors. So if we have a vector with magnitude 1, okay, that means the length is 1, then it's called a unit vector. We talk a lot about the unit circle. We have a unit vector. Okay. So given any non-zero vector v, a unit vector u in the same direction can be written using the following rule. U, for our unit vector, that means that I could have a vector v that has a lot longer, but it has the exact same angle. And so I'm going to be able to find a unit vector for the vector I have that pretty much just gives me the angle, and we'll have some multiplier. Okay? Say that one more time. Like a scalar multiplication type of thing? Yes. Okay. So we'll have information, like we'll do a couple, and then maybe you'll have a different question, or maybe it'll help. But so our unit vector is going to be equal to 1 over this. What did that mean for v? This, the magnitude. When you got that double, that's the magnitude, right? So the magnitude of v times v itself. So our scalar becomes the 1 over the magnitude. If I take 1 over the magnitude of v and multiply it by v, then I get my unit vector. Okay?
But the magnitude is 1.
The magnitude of u is 1. The magnitude of v is not.
Oh.
No, this is not v and v. This is the magnitude of v, which would be a number, like the magnitude is 5. And then the vector itself is this. Okay, does that make sense? Okay. So we have to find then the magnitude. We did that day before yesterday, and yesterday. How do we find the magnitude? Yes, good. So I need to find the magnitude of v first. So that's just the square root of negative 5 squared plus 12 squared, right? That's how we find the magnitude. 5 squared is, you don't need no calculator, 25. What's 12 squared? 144. So this gives me the square root of 169. That's a perfect square. What is it? 13. The magnitude of v is equal to 13. Okay? So to find the unit vector, I take the unit vector is going to be equal to 1 over 13 times the vector itself, negative 5, 12. That means my unit vector then is negative 5 over 13, 12 over 13. That's my unit vector, which is kind of like the vector reduced down to where I got the angle and we know that the magnitude is 1. Okay, everybody good? This is my answer, yes. All right, so y'all do number 8. That is not even close to a lot of work. Uh-huh. Mm-hmm. Mm-hmm. Help? Start by finding the magnitude. I know. Yes, you're doing the next one.
Where's my calculator?
Oh, calculator. I know. Poor little you. Okay, well think about this. No, it's fine. I'm not gonna. If you know that it's a perfect square, think of it this way. You know that 12 squared is 144, right? Because 2 times 2 is 4. That ends the 144. 13 squared is 169. 169 ends in a 9. 3 squared is 9. 14 squared. What's 14 squared? What is it? It's 196. It's 196. It ends in a 6, just like 4 squared. 15 squared ends in a 5 because 5 squared. So if you know it's a perfect square, just think about this like the last number. What would you have to square to get that last number? Because the square root of 225 can't be any of these because they would have to end in those numbers. Does that make sense to you? So if you learned what the perfect squares are, it's a finite set of numbers. And then you can match them up easily, especially by their size. So the square root of this is 15. You do reduce, yes. Yes, we absolutely reduce. And so, yeah, so we get 3 over 5 and what? 4 over 5. Always reduce your fractions as much as you can without making stuff up. All right, we're going to do number 9 together. So let's go ahead and, well, you can go ahead and find the magnitude without me. Go ahead and do that. So we just get the square root of 17, right? And then once we've got that, we need to plug it in. So our unit vector is equal to 1 over the square root of 17. I'm going to multiply that times -4, -1. Right, so you've got a couple of options here. You could rationalize now and then multiply, or you could multiply and then rationalize. And that's, I was trying to figure out which might make the most sense to you. It really doesn't matter either way, and it's really not even going to be that ugly. So I'm going to go ahead and multiply first and get that we get -4 over the square root of 17, and then -1 over the square root of 17. And then we rationalize, which it's ugly looking, but it's pretty easy to rationalize. You're just going to multiply by the square root of 17 over the square root of 17. So it's going to be -4 square root of 17 over 17, and negative square root of 17 over 17. So it's a yucky looking answer, but it really wasn't necessarily difficult as long as you understand what rationalizing is. All right, so you find the magnitude of number 10. Good job, Tony. Good. But that's okay, because if you, but the other ones that you don't really remember, you'll be able to figure them out a lot quicker and reason through them. So it's very good. That really does help you get through things. 16 squared plus -8.
17 was my square.
Okay, so let's just talk about simplifying square roots real quick. The birthday cake, I love. You know what I love, but you know what about what's up going with the birthday cake is that you have to actually do it. You have to do it all the way every time. It's splitting up for every single factor, and that's not always necessary. Look at this right here, square root of 320. Okay, so first of all, you can easily make that 32 and 10, right? Then you can easily make that 2 and 16. Well, guess what? 16 is a perfect square, right? So I'm going to just leave that right. I probably should have put a square when it said. It's a perfect square. 2 is a prime number. 10 is 2 and 5, and those are prime numbers. So I'm going to find my pairs like I normally do. This one, I could split up into a whole bunch of 2's, but I don't need to. I can actually take the square root of that. That's 4. And then 5 stays underneath, and so I end up with 8 square root of 5. Okay, so learn how to kind of break things down quicker, and the more you actually do it and don't just rely on the calculator, the more sense it makes. Use the calculator to check yourself. I am always fine with that. I'm not saying they're evil, but if you never ever practice, then you don't get it, right? Oh, wait, did I do something wrong? Two and 16. This is 320. This is right. Okay. I just have something different over here, and it freaked me out for a minute. Okay, but I didn't work that one out. So this is 8 square root of 5. Now I'm like questioning myself. That I know. That's right. Okay. Whew. Those bad feelings there. All right, so now our unit vector is equal to 1 over 8 times the square root of 5. And I'm going to multiply that by 16 negative 8. I would reduce that, yeah. So like here I would have, I'm just going to go ahead and write every single step. It's okay to skip some steps in between, but I usually don't in your notes because I don't want to lose you, and some of you may not always want to skip steps. But we can make this 16 over 8 square root of 5, and then negative 8 over 8 square root of 5. So before I even worry about rationalizing, which I know I have to do, I'm just going to wait a minute because I can reduce this. This is going to become 2 over the square root of 5. And then this is negative 1 over the square root of 5. Everybody understand how to reduce those things out? Okay. And then in the end, And you can do it, it doesn't matter. So you get 2 square root of 5 over 5, and then negative square root of 5 over 5. So yeah, if you wanted to save it till the end, that's fine. But I always like to kind of get it down as simple as I can, as quick as I can. But there's your answer. Okay, we good on that? Good with that. All right. So let's look at number 11. How's number 11 different? There's 2 points. Now, and I know that they're ordered pairs and it's not a vector. I have to find the vector. How do I find the vector? Okay, I'm actually subtracting, no squaring, and the order matters here. This is vector AB, right? So this has to be x1, y1, this has to be x2, y2. So vector AB, like you can't mix these around. This has to be 6 minus 0 and negative 1 minus a negative 7. And watch your signs because it's so easy to mess it up. So this gives me 6, and then 1 minus a negative 7 is 6. Because makes it plus a positive, so you get 6. So I've got 6, 6. All right, so you do the rest of that one. You can do it. Y'all just get to the square root of 72 and let's talk about simplifying it real quick. Yeah, because guess what? Look, if you pay attention to the fact that it took 2 36s to get your 72, isn't this 2 times 36? Square root of 36 is 6. Square root of 2. Okay? Do you see? So that's why that number sense that I've tried to push with you to keep the calculators out of your hand, the more number sense you have, the more you recognize those things and they become more obvious to you and it's not that big of a deal. Okay? So then keep on going with it. So what you got? Okay, good. I did. Copied right off of you. All right, do y'all agree with me? What questions do you have? None? All right, this is as hard as it gets. All right, so I want you to, on number 12, find the vector, get to the square root. Don't reduce it yet. I want to help you reduce the square root because I want to talk you through a certain way. Even if you could do it a different way, I just want you to see something. So you will have a square root that's not a perfect square, but just get to that point on your own, and then I will kind of walk you through the rest as a kind of a refresher. Because you're doing good. Just want you to know that the other day, what we were doing something like this, and Mrs. Archer and I were talking about whether or not, she was like, yes, I'll let my kids use the calculator, because I was not about to have them do all of whatever it was. But I didn't give y'all a calculator that day. And you know what? Y'all got right through it, because I've been making you do that all year long, and that's very good. Like, you've come a long way. I didn't feel like, oh, I should have given you the calculator type of thing. It was good. I was proud of you for that. What'd you say? I know, but does it help now? It really does, and I know that's why I always say I will make you a believer. It makes factoring easier. It makes everything make a little bit more sense. It's a struggle, and believe me, it would have been way easier for me to just throw a calculator in your hand at the beginning of the year. Okay, I'm going to go ahead and start writing it out. No, it can be simplified. It's just not a perfect square. So let me get to that point, and then what did y'all get for PQ? You should have gotten that right. 9, negative 6. I'm not going to write it all out. Then it's divisible by 9. And if yeah.
If it has 36.
Okay, so here, let me get this. PQ, when you did that, did you end up with the square root of 117? Okay, so let's talk about this. When you want to simplify this, that's not like the 2 times 36 thing, right? And it's not even like I can't take a 10. It's not even, but if I add all 3 of these numbers up, 1 plus 1 plus 7 gives me 9, which means for sure it's divisible by 3. But if that happens and it's divisible by 9, it's also divisible by 9, okay? Now, it doesn't work for 6 and anything else, but it works for 3 and 9. So if these add up and give me 9, I know it's 9 times something, right? So 9 goes into, and then you have to figure out how many times does 9 go into 117, right? So 9 goes into 11 once, and then you got 2 left over. There you go. 9 times 12 is 108, and then you just add 1. That's a beautiful way to look at it, but a lot of people don't know that 9 times 12 is 108. I'm just saying. But when you do, that's why you can do stuff like that. That's why I've been pushing that with you, so that's very good. So this is 13. Now let me ask you this. Is 13 a prime number? Yes. Is this a perfect square? Yes. 3 squared of 13. Don't make things harder than they need to be, okay? Learn those little, that is a trick, that whole adding up, but that's an important trick, okay? So that is 3 squared of 13, and now finish that up. And again, check yourself on the calculator. I'm fine with that. If you don't have a calculator that'll do it for you, then you just square the outside and multiply by the inside. You should get back what you have. But it is a different language. All right, any questions at all for you? Are we all good? Okay. Just like the other day, I'm going to give you your assignment, but, oh, I'm looking at the wrong thing. Dang it, I'm looking at the wrong thing again. One of these days I'll get this right. I'm going to give you your assignment, but I'm going to tell you which ones to do and which ones not to do. Let's see. At this point, I mean, don't, yeah. Okay. So for right now, what I'm giving you, all we have done so far is the front. And you don't have to get it all complete tonight, but I'm going to give it to you in case you don't show back up or so that you have it if you want to work on it. But the back, don't scribble it out. That's what our lesson tomorrow is, okay?